My name is Gerrit Grunwald. I'm working for Azul as a senior developer advocate, and I'm doing Java since 2000, I think I started. And I always was interested in UI stuff because this is for me, how to explain that? Yeah, I really like to see what I do. So the result of my work, right? If I write an algorithm, that's nice, but I can't see it. But if I have a UI, then I can show it to my wife, for example, and then I can get the feedback. So that's why I really always loved UI. And when JavaFX came out, I saw the JavaFX script stuff. Before that, I was doing Swing, a lot of Swing. I also wrote libraries in Swing. But JavaFX caught my attention. But then it was JavaFX script, and that was like, it wasn't really that nice. So I never really used it. And then when Oracle ported everything to Java, I went to JavaOne and was approached by some people from Oracle, and they told me, "Oh, you really should try it." And yeah, on my way back from San Francisco to Germany, I tried it, and from that moment on, I was totally into it. And I think I did everything that came to my mind with JavaFX over the last 10 years or longer.
You said when you traveled back to Germany, that you started experimenting with JavaFX. You are a DevRel at Azul. Isn't that the time when you built most stuff in trains, planes, waiting rooms?
It's a lot of airport and train and flight coding. Yes, it is.
You created a lot of libraries, a lot of applications. I have a very hard question for you. What are the best things that you can show us that you have created?
That's a good question. Because to be honest, all these libraries I created, there was never really a real use case behind it. So it was just my curiosity. So I thought about something, and then I thought, okay, maybe I should create a library. So I created the library, and once I finished it, it was done. So off to the next project. So this is how I usually created all this stuff. So I have so many different things. The most stuff I did was about gauges. And that was because when I started with coding UI stuff in Java, that was in Swing. I worked for a company that was working in the nanotechnology area, and we had our own tools, and I needed something to monitor that tool. So I needed a gauge. So I asked the CTO of the company, and there was a library for Swing, and then he said, that's too expensive. We won't buy it. So I was like, so maybe I should try creating that on my own. And that's when I started doing that. And this was the best time coding UI because I learned so many things, and I found out that I really like it. And that's not so hard to do. When I started with I think it was called Steel Series. That was my first library in Swing, which is mainly gauges and I think clocks. And then I moved to JavaFX, and then I started porting this stuff to JavaFX and didn't really work out the way I wanted to be. So I started Medusa, which is again a library about watches or clocks and gauges. And then the main purpose was to make it as configurable as possible. I finished it because I started a new one, because I was in a project at that time working for Canoe in Switzerland. And then these guys said, oh, we need some kind of a dashboard. Just one dashboard with a gauge. That was everything. So I was like, okay, that's easy. So I did that. Then I did the second one. I was like, oh, this is really cool stuff. So I added more and more and more. And I think this is the library with the most stars on GitHub. I think it's around 1,400 stars or something. So lots of people use that. This is more or less all the tiles that I have. And you see, it's a lot of stuff. So you have bar charts, you have clocks, you have gauges, spark lines, area charts. I don't know. I have countries, radar charts, spider charts, fire. This eye, you see the blinking eye, which is just a matrix. All kinds of things. It was really like a playground for me. If you create dashboards, you never know what you need. So I was just looking on the web for all kinds of dashboards that I found, and everything that was interesting, I just added to my dashboard. And it seems people like it.
In my book here behind me, There's also the TilesFX library, which is used to show on a Raspberry Pi some temperature measurements and stuff like that. So indeed, it's great to build something very easy. Maybe you can show in the code how easy it is to create a tile like that.
If you create these UI libraries in JavaFX, what I do is I usually have one control, right, which is in this case, it's just tile. And if I open that one, you will see that it's huge. So you see it is around 7,800 lines of code. This is just the tile. And the reason for that is that I decided to go in the direction that I have only one control, and then you can add different skins, because in JavaFX controls have skins. This is the UI representation of the control. And because I have all these different skins that you saw in the demo, right? If you take a look here, then you see I have a clock. And here it's just the flipping character. And then here I have a fire and all these things. And this is all baked by one control, right? So that means this one control needs all the properties that you need for all these different visualizations. That's quite flexible in the end, because in the UI part, you only can focus on the stuff that you need. Could be just one or two properties, because no UI part will show all the properties, right? It's just too many. But you can imagine that the code is quite complex because it's just a lot of code for this control. You see, these are all different. This is events from all the, I have my own event system, and these are all the properties here. It's lots of properties.
But these 7,000 lines of code, that's your problem because that's it in the
Exactly, that's my problem, which is fine. I mean, because this is really, it's a simple control. That means it's really properties and events, and that's all what it does. And that means it's not really so hard, right? So it's just a lot of code in one class, and it doesn't really make sense to split it into multiple files. So it's because this is the heart of TilesFX. And then I have all these skins here. These are all the different skins. That means this is the UI visual representation. Let's take a look at one, the simple one, LED tile skin. So you see, this is just 200 lines of code. And to give you an idea what I'm talking about, I think it's this one in the middle with the description, the green LED, right? And it has different visualizations. This is just the flat UI, and I also have like a more three-dimensional with a highlight and all these things. But it all depends on where you show it. And the main idea is you have a title, and then you have the LED, which can change the color and stuff like that. And the good part is that for this stuff, I only need, you see it has highlight and things like that. I can switch it on and off, so it's different modes. And you can simply switch it on and off, the control, the LED control. And then this one will react to that. So I have handle events. And then you see, wait, these are the different events. There's a redraw event. I love to use Canvas, because then I have everything in one drawing method. And in JavaFX, you can also do it differently using the scene graph, right? But for my approach, because you saw it's quite visually quite rich. And if you do that in the scene graph, then it means you create a lot of nodes, right, in your scene graph. And for example, in this demo here, I think this is just, I'm not sure, but it's not really so many nodes, because most of the stuff is canvas. And in a canvas, it's just one node, and then you can draw in this node. And that means you can keep the scene graph very slick or small, and that makes it performant. This is the main reason why I use the scene graph. Not so much the scene graph, but the canvas, because canvas is really fast. It's hardware accelerated. It's just one node, and you can draw everything in one node. If you have stuff like this water effect here, or this aqua thing, let's take a look at that one shortly. It's this one, fluid tile skin. And you see, this is 400 lines of code. Even this is not really huge. And you see, this is the stuff where you have the canvas. This is the graphics context, the CTX. And I clear it, and then I just do the drawing. And this is mainly particles here. So but this is the whole code. It's not really a lot that is needed to run this stuff. And that's what I like about Canvas. You can really draw lots of things in a very compact way.
I think I saw blog posts of you in the past where you
Mhm.
described how you create very complex charts,
Mhm.
radial charts, where you actually just draw some circles on top of each other on the canvas,
Mhm.
and you get very nice visual results, which are, I think, then much easier to create by drawing on the canvas than you would do with nodes.
Yeah. I figured that out over years. So when I started with this whole graphical coding, I realized that I started with Swing, right? In Swing, it's very similar to the canvas. You have this graphics 2D, and then you draw on the graphics 2D, which is very much the same approach. And I like that a lot because it's like a hierarchy, right? You start drawing, what you draw first is at the bottom, and then you draw on top of it. Canvas is exactly the same. And what I do, what I learned over the time is I use a graphics program. I use different ones. Typically, it's a vector drawing program. And because what you do when you code graphically, you draw by using code. This is what you do. If you know how to draw manually or using tools like a vector drawing program, and you know how to do that in the drawing program, it's way more easier to create code because you exactly know how you have to do it, and you can play around in the graphics program. And the good thing is the graphics program is made for that. So you can really just try stuff easily and then delete it again and try other stuff, try gradients and the effects and all these things. Once you have it, converting this into code is pretty simple because for most of the stuff we have commands, right? Like circles, gradients, colors, and all that, borders, and it's the same in a drawing program. So you create the drawing first, and then you convert it into code. This is how I do it, and with this you can really create good looking stuff. What I also did a lot in the past is I take pictures, put them in the background, and then I draw with vector graphics on that picture and try to recreate it with vector graphics using gradients and all these things. And then you do the same in code. I even wrote converters that convert SVG and other formats into code directly. And with this, you can do really complex stuff that looks cool.
You also have a lot of applications for
Mhm.
your own use or public. Can you show some of them? I saw messages of you about a background for Zoom that you created with JavaFX. Then you have some very nice animations that you use in your presentations about the garbage collector. So
Yeah,
I'm sure you have more things to show.
I created a background for Zoom, and that was with the graphics program. And then this was the Azul logo, and it had this. It has some lights with shadows and highlights and stuff. So, and when I finished that, people said, "Oh, this is a really cool background. Where did you get it from?" I said, "Oh, I just created it. It took me 10 minutes." And then I saw it and was like, "Oh, it would be cool if you could have the light going around the logo, right, in a circle." And then I was trying to do that with Apple Motion, and I realized this is just overkill because it will take forever. So I decided, oh, I can do that in JavaFX because this is so easy, right?
And because you can do everything with JavaFX.
Yes, exactly. So this is an SVG. It will be loaded, and then I fill the background, and then I just move a light around, and that's all.
That's something people probably don't know. You also have within JavaFX a whole 2D and 3D environment
Yes, exactly.
and cameras and lights. And can you
Yep.
maybe show some of that code?
This is all the classes. The launcher is just for launching it. It's not really, there's no code in here, as you can see. It just launches the application. And that means I have a helper class, and you see it only has two methods, right? It can read a text file and it can get a path from an SVG file. That's all. And the other thing is constants. And here you just see some patterns that I use to pass the. Oh, I'm a big fan of regex, so this is why I use them everywhere because they are so
Okay.
powerful.
I finally
Um,
found someone who loves regex.
oh yeah, I really like it. I use a lot of this stuff. So what I did is I have the Azul SVG. Here you see path, and this is the move to, and then line to, and all these things. So this is in principle the SVG string. You see, it's quite long. It's the whole pattern for the Azul logo. So this is just one path, this thing, right? So what I do is this, I put this in a text file. Then I read the text file, and then I just parse for this string. Instead of writing a parser for SVG, doesn't really make sense because JavaFX can already draw SVG, right? There is a thing that is called SVG path, right? This is a JavaFX component, and you can just put a string in there. And then I just load the text file, the SVG file, pass this path out of it, and then I put it into the get path from SVG file. So I load the file, get the path, and then here I create the SVG path and I set the content. And this is this string. I set it to the logo, and that's it. That's everything you need to do to draw an SVG file, which is pretty simple. Then I scale it a little bit bigger, so in the size I would like to have it. And then I put the lighting, which is the effect, right? So here you see I have lighting, and I said it's a distant light. So I first create a light, which is a distant light. You set the azimuth, the elevation, the color of the light, it's just white. And then I create a lighting where I can put some other components like diffuse constant, specular constant. That means it's how the light really reflects on the surface and all that. This is for the JavaFX 3D stuff mainly. So the next thing I have to do now, I have a timer, an animation timer, pretty simple here. I just rotate the angle for the azimuth in this case, and that means it rotates the light around the logo. That's the whole thing. And then I call that every 50 milliseconds, I think. That's it.
And you can simply swap the image with something else and have the same
Exactly.
effect.
So whatever you like, you can just load it in there, change the colors. But this is the whole thing. It's really, really simple. It's not really hard to do because JavaFX is just powerful. You can use it for all kinds of stuff if you know how to do it. And that's mainly because I was playing around with JavaFX so much that I always, when I would like to do something, I know I can easily do it by using some parts of JavaFX, right?
Probably the same with the animations you created for the garbage collector.
Yes. So
dog.
this is a little bit more complex. So this is for the trash talk that I do at the moment. So I had the problem explaining garbage collection to people is really not easy because it's a very complex topic. And if you would like to break it down to the most simplest approach, then you will figure out it's still very complex, right? So it's really hard to explain it in words. When I started doing the presentation, I had around 270 slides, and everything was describing how it works. And when I read through it the first time, I realized, okay, for the first principle, everybody will fall asleep after 5 minutes because it's way too complicated. So I thought about what can I do to make it easier? And I thought, okay, maybe I can just create an animation of how it works. The problem is that's not so easy because what you have to do, you have to fake a garbage collector, right? At least a little bit. So that means you need something like a memory cell, then you need some kind of an allocator that allocates memory, and it has to check if the memory is available, and then you need a collector that collects memory. The memory cells have to die after some time, and you can only collect the dead ones and all these things. So the code is a little bit more complex, and I split it into different. So that means I have a region-based collector. Mark and sweep is the simplest one. And you see for all of them, I have an allocator, a collector. I have the algorithm itself. The most complex one was the region-based collector, which is an idea how, for example, G1 works in the JDK. And this is exactly the thing that I used for the recording. So I created the animation, recorded it with a screen recorder, and then I added the movie to the slides. So I have the regions here, and then I started, then you see now it's allocating in the Eden spaces, which is the yellow ones. And I think I have 6 Eden spaces. And now you see objects will die. That's when they get darker. And now it's doing a garbage collection, and evacuate the stuff into the survivor regions. And then when they are filled up, I think it's 3 now. Now we will see an old generation once. Okay, here we go. And now this continues all the time. But with this, it's way easier for people to understand how it works instead of explaining how it works, because that's so complicated. But if you see it, you get the idea. And you see that it's way more efficient because the regions are smaller. So that means garbage collection is faster and all this. So this is the main idea. But as I said, this is way more complex than the other ones.
You really implemented the garbage collector in a JavaFX visualization way. So you didn't simply create an animation.
No, I had to do the garbage collector really.
You
Otherwise,
really created a garbage collector in JavaFX.
yeah, just at least the principle, right? So I have a list of object region, right? And an object region is, in principle, we can take a look at the object region. This is the control. It's 230 lines of code. And what it is this is a region, right? One of these bigger squares. And you see it extends region, and I give it some size. And again, it's canvas, right? So that means init graphics, you see it's very small. I create the canvas, and then I add it to the region itself, and that's it. And then I have this, where is it? There's a redraw method. What does it do? Yeah, and here we see all the stuff happening. So I have to draw the metrics, right? I started first with, let me see, because I also have the other ones. I should have mark and sweep. For example, this is mark and sweep. You can take a look at that one. This is way easier because this is just one matrix, right? So this is in principle one of these regions. So you just can allocate, everything's free, it's easy to allocate. And then once I fill up, there's no place anymore. So I have to stop the world, mark it, remove it, and then continue, which is, that's the whole procedure. And this will even get out of memory exception at some point. If there's not enough space, then it will just run out of memory. That can happen. Because the objects also have a lifespan. So that means I remove them with a separate thread. After some time, set them to dead. It's the purple color here. So that means they die, and this is random. So sometimes if you are not lucky, then they really live for a long time, and then you run out of space. So yeah, so I really had to think about how a garbage collector and allocator, how the memory system works. The first time I saw, let me show you this one, because that was for me that was the eye opener, the copy collector, because that's really cool. So this is that was the best one of all the collectors, because when I saw that the first time when we started, you will see that once it fills up and you have to stop the world, toggle the spaces and copy all the live objects to the new to space, then it's directly compacted. And that's, you only can see that now. Move, and you see it's directly compacted and it can continue allocating. And now, because the other space is empty, it's the same again. And when I saw that the first time, I was like, oh, this is so cool. The copy collector is automatically compacting. I knew it before, but when I saw it, I was like, oh, this is so cool.
Yeah, the garbage collector, it's a fascinating subject where, as most Java developers don't need to worry about it. It just handles. But if you know that there are different ones and how they work, and how some use cases are better with another garbage collector, but the way you visualize it here is really great, because it's indeed pretty hard. I wrote a long blog post a few years ago about garbage collectors. I know how hard this topic is.
Oh, it's so complicated. I mean, and when you only have text, it's really hard to describe. And because you have a picture in your mind and you try to describe it, but for people to follow, it's nearly impossible. So, and that's why I created this graphics. And for this one, for example, it's just a combination, right? This is generational garbage collection. But if you see it, how it works, it's like, it makes so much sense. You allocate an Eden, and then only the live objects went into the survivor spaces, which is a copy collector. And then if they survive long enough, you promote them into the old generation. When you see it, it's just way easier to understand. And so this is how I use JavaFX at the moment. So it's if I need something, I code it because I know how to do it. But this is probably hard if you start with JavaFX, because then you can do so many things, but you need some experience to do it right. Otherwise, you can also mess it up. That's one of the problems that I saw when I started with JavaFX.
Isn't that a problem with all languages and
Yeah, the
frameworks?
problem with JavaFX was the problem that if you come from this swing approach, right, that means you just you draw everything, then you just create objects and you don't care. But in the scene graph, you can't just do it because nodes are expensive when you draw them. Because in the scene graph, everything it's like a graph, right? And when you draw it, it has to go through the whole graph and draw everything. If you change something below here, it has to go to the parents and up the graph and back again to change all the properties. And that can really slow down stuff. And if you don't know how JavaFX works internally, then you can create some apps that look nice, but they're really slow. And then you wonder, how does it come that it's so slow because it's hardware accelerated? Well, mainly it's because you don't really care about the number of nodes that you draw. And this is something that you have to figure out first, because then once you know that, and this is one of the reasons why I use Canvas a lot, because with this you can make sure that it's only one node and you can do quite complex drawing in that node without really polluting the scene graph with nodes.
I have a very nice example comparing a lot of nodes versus drawing on the canvas with just circles.
Yeah.
Adding a lot of circle objects versus drawing a lot of circles on the canvas. I will add a link to the show notes, especially when you have a lot of components or a lot of visual elements. Then drawing on the canvas is a lot better.
And there are also tricks in the scene graph that you can do, right? So especially when it comes to effects, you should never apply effects to one object only. But if you can group them, then you just apply the effect to the group, and that makes it way faster. But these kind of things you learn. This is nothing that is well described somewhere. Especially if you go on embedded devices like the Pi, then everything counts, right? You really have to make sure that it's fast, and that means don't use lots of effects and stuff like that.
How do you see JavaFX evolving? You mentioned embedded, mobile. Those are two of those fields where you don't see a lot of JavaFX. What is the future, according to you, for JavaFX?
I like the API. I really like it because I know it and I can use it for all kinds of stuff. But the future is probably not that bright. JavaFX never really took off, right? Because and you can see that because we don't really see a lot of third-party libraries. We see some, but if you compare that to Swing, there are not really a lot of companies that invested in JavaFX to create libraries that you have to pay for. Right? In Swing, that was normal. There have been a lot of companies, they created Swing libraries, you paid for it, it was fine. With JavaFX, somehow that never really happened, which is a little bit of a problem because people just have the impression, it's not doing well, it's not really supported. So they hesitate in adopting the technology for years now. And in the meantime, we have web everywhere, and we have also web developers everywhere. So that means it's hard. But I saw a lot of JavaFX in big companies for internal projects, and for this it's just cool. I mean, business applications, there's nearly nothing better to do that. If you have Java developers anyway, it's easy peasy to do JavaFX because the API is really simple. And if you can even use FXML, and then you can use the UI builder to create your business UI, which is cool. And for this kind of stuff, the scene graph is great. I still love it. I mean, I use it for all stuff that I can use it. I use JavaFX to do that because it just works and it's fast. So if you know how to do it. I did a presentation about Java on desktop a couple of years back. It's not that long ago, maybe 4 years, 3 years. And you will be surprised if you see how much Java is used on desktop. It's used a lot. There's a lot of software out there, which is good software, right? So it's not bad. I mean, all the desktop stuff it's really cool. It's fast. It has all the features that you need, especially for desktop. JavaFX is cool. It's absolutely recommended, and you can create very complex applications in JavaFX. I saw lots of stuff from Airbus, for example, where they use JavaFX to do simulations of wings and all these things. It's really cool things that you can do with JavaFX, and that is used in this kind of industries. Unfortunately, this is not visual or not visible to the public. So the people have the impression it's dead because you don't see it. But I know that it's used a lot in big companies internally. And why should they talk about it, right? So for them, there is no reason to say, oh, we're using JavaFX, right? It doesn't make sense. And that leads to the fact that many people think this technology is dead, and it's not.
Well, maybe we should do this video interview again in 5 years and see what has changed.
I will still use it. So I mean, I use it for
That's
so
clear.
long. If it's still around, I will use it. I won't switch to something else.